Hey there. So we are going to be looking at the concept of moles, molecules, and mass in a balanced reaction. So the first thing that we need, of course, is a good example of a balanced equation. So we're going to look at this and we're going to say, first of all, that the coefficient of 1 is understood to be there. And I'm going to make the statement that the coefficients here represent the number of moles. So for example, if I say 1 mole of N2 reacts with coefficient of 3, 3 moles of H2 to produce coefficient of 2, right? 2 moles of NH3, you can see that this is an interesting example of where, mathematically, 1 plus 3 obviously does not equal 2, right, mathematically. However, that kind of relationship doesn't hold true when we are dealing with moles, right? The term is called conservation, right? So we would say that moles are not conserved. So by conservation, what we mean is that the quantity adds up and is equal on opposite sides of the reaction. So let's do this a slightly different way. Let's take a look at molar masses. So the first molar mass we'll take a look at is, of course, molar mass of nitrogen. And its molar mass, I'm just going to move that up to the top here, I think. And its molar mass is 14.0. So we would take a look at N2, notice that it is diatomic, and as per the previous video, hopefully you watched that one, the mass of 1 mole of N2 gas is 28.02. Then we next need to take a look at hydrogen. So hydrogen's molar mass is 1.01. We'll move that over to the top here. So when we look at this balanced equation and we ask ourselves what's the molar mass of H2, it's going to be just 2.02, right? Because again, remember that when we find molar masses, it's always the molar mass of just 1 mole, right? So I'm going to go ahead and say molar mass in grams is always the mass of 1 mole. Okay, and last but not least, we need the molar mass of NH3, and since we have 1 nitrogen and 3 hydrogens, that's going to be 17.04. And you can see that these numbers do not add up mathematically, right? So it might look at first glance to be true that mass is not conserved. But remember, this is a balanced equation. So the thing that we have forgotten to apply here are the coefficients. So I'll emphasize again that this coefficient is 1, this coefficient is 3, and this coefficient is 2. So in reality, what we were using here was not just 1 mole of each of these, but the appropriate number of moles. So let's rewrite these grams one more time, and let's go ahead and go 28.02 grams. Sorry about that. 28.02 grams of nitrogen. But now that I know I have 3 moles, right, because I have 3 moles of hydrogen, I'm going to take this 2.02 and I'm going to triple it, right? 2.02 is the mass of 1 mole, so if I have 3, my mass is going to be 6.06 grams. And then on the product side, I'm going to take this mass of 17.04 and I'm going to double it because of the coefficient of 2. So I'm going to end up with 34.08 grams. And what you're going to notice here, of course, is that those masses do indeed add up. So we would of course say that mass is conserved. And again, the meaning of that conservation is that mathematically the numbers add up. Okay, so the last point we're going to make here is we're going to make the connection to molecules, and we're going to say that we know that 1 mole is equivalent to 6.02 times 10 to the 23rd atoms, or in this case, since all of these things have subscripts, molecules, right? Remember, that's a value from the first video. So I'm going to say directly underneath this that not only is 1 mole equivalent to 28.02 grams of nitrogen, but that it is also equivalent to 6.02 times 10 to the 23rd molecules of nitrogen. And then, if we look at the fact that we have 3 moles here, and we multiply this number right here by 3, then we're going to end up with 1.806 times 10 to the 24th, and that would be molecules of H2, produces, and then again, if we take a look at that coefficient of 2, which we know is moles once again, then we're going to end up with 1.204 times 10 to the 24th. And by the way, if you're confused about where the 24 comes from, break out that calculator and multiply 6.02 times 10 to the 23rd by either 3 or 2, and you'll notice that the 6 ends up being doubled or tripled, which means it's over 10, and when the number gets bigger than 10, you have to adjust the exponent, right? Make sure you're doing this on a calculator. So 1.204 times 10 to the 24th, and that is going to be molecules of NH3. And so you're going to notice here that those numbers do not add up. In fact, this one in the middle is the biggest value of the 3, and there's no way that a big number and 6.02 times 10 to the 23rd is going to end up equaling a smaller number. So what we would say is that molecules are not conserved. All right, so that's our attempt to talk about 3 things: moles in a balanced equation, mass in a balanced equation, and molecules in a balanced equation. Okay, hope that helped.